And now I would like to welcome Reagan Wytsalucy.
Thank you, Helen.
You're welcome.
It's nice to meet you all. I see a few familiar faces, so it's been 4 years. We were counting back the years, 4 years since I was last here. I'll just introduce myself really quick. I work with Utah State University Extension Office. I am the county director for our county, so I oversee everything that our extension department is doing in San Juan County, and I'm also the agriculture extension agent there. I got my master's and my bachelor's degree over at Utah State University in plant sciences, and I specifically focus in horticulture systems, notably Native American systems. So I'm actually being asked to speak on permaculture or speak for permaculture workshops and things like that, bringing in a lot of the aspect and the natural scope of how Native Americans did agriculture practices before the change up in how we know agriculture today. So I grew up in Gallup, New Mexico, and I'm half Navajo. I'm Nakai Diné, which is the Mexican people's clan, so that's my mother's first clan. I was born for Sinchakini, which is the honeycomb or cliff-dwelling people's clan. And my mother's paternal grandfather is Bilagana, which is another name for white or Anglo. And then my father's paternal clan is Totachitni, which is the Bitterwater clan and is one of the first 4 original clans of the Navajo people. So today I'm going to run through a recap of what some of you had heard 4 years ago, just to get everybody's minds back up and going on this, and then we'll get into a lot of the stuff that I'm working today, and even stuff that is outside of this scope. We'll start to touch on that and kind of the direction I'm moving forward and why I'm moving forward that way. So I've studied 2 crops, Navajo spinach, which is also known as Cleome serralata. There's a lot of backstory on this. But also the peach, which is what I'm here for, just to give you that update of where we're at. So, going the wrong way. That's the spinach. By the way, I guess if you want to take this into a photo show, this is, information on the Navajo spinach, the journal article that we published on this. I haven't done any more work on this plant since I graduated with my master's. But we are kind of starting to push and bring that more into some of the permaculture work that we're starting to push forward, and I'll touch on that later. So just really quick, beginning introductory thought by the Spanish, huge destruction period where over 4,500 peach trees were torn out of Canyon de Chelly through Canyon del Muerto and Canyon del Chelly in the 1860s that led to the Long Walk. So this was a part of the Scorching of the Earth campaign that was also going on in the southern states during the Civil War. The Long Walk, just so you know, over several hundred miles that our people were forced to walk. Fortunately, my family, my ancestor that lived at this time was not a part of this Long Walk process. He was actually a known raider chief in Monument Valley and Navajo Mountain area that was never captured, but continued to take care of the feral livestock that were left at the time when the people were taken away, and also the orchard, one of the orchards he cared for that still was not in destruction, but the U.S. Cavalry never found him, and he stayed there with our family, and that's how we were able to stay safe. So I've actually gone back to that orchard, and that's where some of these samples have come from. So it's kind of just a really interesting giving back history. So early known history, peach propagation, these are with the Hopi Nation, and how, just demonstrating how they would harvest. You split the peach in half to remove the pit. Very easy to process. They're the size of an apricot. No pruning, a lot of different things associated with them that we selected them to make them very easy to process and store. So several uses are very similar to what we would associate with other traditional foods that we have grown and harvested for centuries. And so preserving them dried in the same storage spaces with the corn, with the beans, with the squash, even with melons that have a very hard husk that store and retain their moisture. So we're looking into quite a bit of different things with traditional food sources. And it was an important trade good. These are the 3 tribes that I worked with this early part of the project. This is my dad's family, here on this side, this is my dad right here hugging the dog, and it's just really funny. He's got a good relationship with dogs even to this day. But you can see between these two pictures, this is a picture I took back in 2015, and these are all fruit trees in the back, and none of them exist back in this area here. So this is just, and instead we've got Russian olives actually growing up in this area. This was their garden down in Shanto Canyon. So what did we want to do? I wanted to know where the peaches came from. Wanted to start recording and preserving the traditional knowledge, the uses, like how did we care for these trees? What was the process of even getting a seed and starting it to germinate? You know, we didn't have a lot of fancy techniques, but we were propagators. We used scientific methods in a lot of ways without knowing that we were actually doing science. So how do we record that, preserve that, and then start to give credit back like these are scientific processes at the same time? We wanted to know how, like genetically, where they placed with a lot of the other peach genome, which we'll get to. Like, I'm still working on that. It's been a process, but it's actually grown more than what I ever imagined this project to become. So we'll get to that. And then we used dendrochronology. So I did dendrochronology work with this just to start seeing if I could, cross-date. Like, how old were these trees? Could we cross-date with other trees in the natural landscape to see what time period they lived? Because I was being told by my father and several other people, we've had these trees longer than even the Spanish. Like, they're a part of our cultural ceremonies. There's a lot of significance behind them that even starts to relate to corns, beans, and squash. So do we really get them at a point and then add them to our prayers and our ceremony songs? Or is this something that we've had and it's been a part of what we've known for many centuries? So interview questions, something very simple. I went to elders in all these communities. I asked for their input. I learned a lot from them, not just about the peaches, but about a lot of different things. Some of them shared a wealth of knowledge. And so I also wanted to know, like, where were these located? Do you know where orchards were located where they're no longer growing? Because now, today, there's less than 2% of them that are actively thriving and living within these communities of where they were historically growing. And that's throughout all of the tribal communities that were growing them, not just Navajo, but also I think Hopi's starting to get back up and starting to put them back together. But we'll look at some things that are going on in Hopi right now that could hinder some of that process also. Seed propagation, this is what I found from the elders. So in Zuni, there was, most of them are seed propagated. So they're not genetically alike. We're not taking cuttings. That was a question like, can you propagate them? Can you take cuttings? And I'll show you some of the work that we're doing on that too. Elders, none of them, all these elders in their 80s on up. Some of them were 50s, 60s going on up. The ones that were in Canyon de Chelly were the elders that were actually repropagating and reseeding these trees, actively growing. And I think that has a lot to tie into the history behind where they're actually located and trying to repropagate these trees in an area where they were once cut down and removed. In a lot of these other areas, though, where that destruction had not taken place, these trees were there for a long amount of time. And so we started to look at the dendrochronology with them. Pruning is a cultural no-no. You're cutting off life at the start of its success, its opportunity to succeed and to be able to flourish and, and going on and continuing future generations. So pruning was never done, thinning never done, and we encouraged additional growth. And so these trees are actually growing as a multi-stem shrub in a lot of these areas. Very dwarf. This is actually a large tree, and you can tell it's getting more water than probably some of these other trees that are not next to a house because it's got runoff from the trees coming off and collecting. This is in Zuni, and so this is on top of a mesa shelf. There's more of the mesa at the top here. This is the valley down, and the Zuni village is way back down in here. And this is where one of their original orchards, there's 5 historic orchards in Zuni that I was able to track down and find. This one had 2 trees living at the time. And there was one other orchard that also had 2 living trees that were more beneficial, and they're definitely getting a lot more water collecting there. But none of these orchards ever had assisted irrigation at any one time in Zuni, ever. And so with the extensive 20-year drought that had occurred, these trees were barely hanging on. So there's one here, there's one here. That's me right there. This is my lead major professor walking down here. I can't remember who that is out there. That might, but we we started to look at some of these sites and like what made it possible for these trees to be able to grow without the irrigation. We had the extensive drought. There's also a part of our beliefs that ties into this whole thing. So there's the physical, and then there's also the spiritual, social, mental, and environmental processes, and we can talk about that too, and I can explain that further. But it was something that I was starting to learn and what was being taught to me, that the spirit of these trees is connected to the caretaker of these trees. And when the caretaker passes on, and I kid you not, every orchard that like where an elder is passing on, there are some trees that do die off unexpectedly, and they go with them. And so this is very evident in a lot of also what's contributing to these orchards passing on is, as there's not been a caretaker to replace and continue to look after, the trees do not have a purpose. They don't have a spiritual connection with a caretaker, and thus there's no purpose for them to continue to try and survive. So that's also something that I want to lay out here. Obviously, there's no scientific evidence to prove that, but as we see, there is such a thing as observational science, which has reduced credibility. So I'm going to bring that aspect in and say, yes, we can observe this, and we can say this is an observation that is continual, and there is a commonality process that we are seeing and recognizing in this process. So sandy soils, no irrigation in Zuni and Hopi, and with Navajo, this is what the elders are saying, by the way, okay? And we're actually going to pair this very well with dendrochronology. And so the Navajo, they did irrigate every once in a while. The trees were grown in actually canyonlands, so where the water's collecting. They only watered in the first few years just to make sure that the trees would get established, their root systems would be able to go down. They encouraged deeper watering, very infrequent watering cycles until those trees got into the water table, and then they would be sustained by that, okay? This is the pathway down. It's very rocky terrain. A lot of these orchards in Zuni were like this, very hard to find, very kept out of the way. In remote areas, you had to walk, hike. There's a storage house. If I were to go back, this is the old house that was originally built there for the caretaker that would be there for the orchard. I don't know how old this actually is, but families remember going up and using this house, and it's been there for a very long time. Harvest, this is what the peaches look dried. I'm sorry I couldn't bring peaches to you today. I ran out, and I'm waiting for another harvest. We've had some cold freezes, and so we don't have any of those today, but they were stored for uses. And then again, they were rehydrated in stews, so they were made into like a fruit soup, which is very similar to what some of the Sioux and Lakota tribes do with some of the berries that they harvest out of the forest, and then they dry and they store them, and they'll rehydrate them, boil them, and then they'll just eat that as like a very nourishing broth and stuff, especially in the wintertime. So, and then also that it's paired with some traditional breads as well. So it's just kind of like, okay, so we found ways to make sure that it was incorporated into our cuisine, right? So if this is introduced, that's how we utilized it. Now, what's really interesting is when I asked the elders, like, where did this come from? Do you guys have stories of like your family inheriting this, or are people inheriting this, and what are those stories? So first off, in Hopi, they are, being the oldest, still continually lived in civilization. They have a lot of archaeologists and historians coming through, dating their home sites and their archaeological sites, and they're giving that information back into the community. And so what's being transposed is what the community is repeating back to me as how I see it. But one thing that's really interesting is right here. Like, they have their spring ceremonies timed specifically from when the peaches start blooming, they start their spring dances. And when the peaches stop blooming, they stop their spring dances. And that is something that is an embedded process. We don't change our processes of how we do our dances, our ceremonies, and how we follow all of those. That is just something that is not changed. If an elder knows it and they die off and they did not pass that down, we do not try and recreate it. We just don't. We just accept the fact that it's lost. And that's what it is. And so this to me is really significant, that even though this is what they are being told by scholars, this is still something that is embedded in their culture today. Zuni, the oldest elder that I talked to, she was in her 90s. I'm sure she's probably passed on now. I haven't been able to go back and reconnect in the last few years. But they have, she lived in one of the main village houses, and they were having it remodeled, and the construction company or the crew, they saw a door in the floor when they were removing the floor. They pulled it open, and this lady, she's like, when they're coming and telling her, they go through this door, and the house is set up just like you would see in a Pueblo honeycomb ruin. There's a level and a level, and so they're going through the rooms, the little rooms, the little rooms. They get to a room with a storage with old seeds, old pottery, grinding stones, everything. And it was like there was this old little cutout cavern area, and there were peaches sitting in there. And so they never had that dated. I asked them, what did you do with it? She says, we contemplated asking them to call the archaeologist and to come take a look and date everything underneath below us. But this old woman, growing up in this house her entire life and living there her whole over 90 years, had never known that door was there. And so she said, no, this is our gold, that's our treasure, that's part of our family. Nobody's going to come in. If they come in, they're going to take it, they're going to date it, they're going to, remove that piece of our family history, and we're just gonna leave it. That's our treasure. So she asked them to seal it up and put new flooring over the floor, so they know it's there, but they're not letting anybody come in. And so that's really significant. We don't know how old that is, but the Zuni village has been there for centuries. And so what you see today is the top layer of what was existing below in the lower layers. In Navajo, I've never been able to trace these down, but I've had accounts passed on to me that they've seen peaches and peach seeds sitting in old Anasazi ruins around Navajo Mountain and Monument Valley and a lot of the canyon areas. And I can believe that because that's a lot of untracked, untraced history that's not been looked at by archaeologists. So when I went around and started actually gathering these seeds, here's where the story actually starts unfolding. It's like, okay, so we get all these stories. It could just be word of mouth. It could just be stories that people are coming up with. But where's the science to prove it? And that's what I kept hearing is you got to have the science to back it up. You can say all you want. People can say all they want. But where's the science to prove it? So I got seeds. We germinated them. We explored lots of sites all over the place. And this took years. I think I was still collecting seeds, and I'm still collecting seeds even to this day. We'll go on to what that even looks like. But this is the peaches here in this cove here. And that's about how much of that tree was still living. We didn't have any blossoms, nothing, but just barely any life, and the rest of the tree is pretty much gone. But we went through, we explored a lot of things, we saw a lot of things. This is the Canyon del Muerto, a lot of fun adventures that we had even before I had kids. And we germinated them, and I had the first set of seeds I got from an elder in Canyon del Muerto, and she said that her seeds were sitting since the 80s in this bucket. She just kept them. She was told, just keep seeds. And so that was the seed she kept. All the other seeds she didn't. And she's got her house, winter wood-burning stove, very uncontrolled temperature type of a structure. Summer heat, may not have air conditioning, all of these factors. And so when you look at seed storage, you're like, that's a really bad condition. Are we going to get any to germinate? I had, I think she gave me 18 seeds, and I had 12 germinate. So pretty good success. So we did, and we're not going to go through all of the genetic technicalities or any of the research technicalities. I can explain that further. But went through and did dendrochronology. This is one of the old orchards in Zuni. It's funny, you go and you hike out, and you would think this is just a juniper tree, but you hike up to the top, and this is at the base of Doyalani, which is their sacred mountain called Corn Mountain. And you look down, and this is what I was told. They said there was over 300 peach trees there at a time, and they died off much, much earlier. Not a lot of people remember or even know that orchard existed in this area. They said hike up to the top of the trail and then look down, and you'll see them. When you're walking up, it'll just look like a bunch of dead juniper trees, but when you walk up to the top, you'll see that they were planted and placed in lines and precision. You have to get up to the top. And so we found it, and they said you can go and take those trees and sample them and let us know how old they are. So that's some of the trees. This is another orchard out in Navajo Mountain over by one of the canyons. I sanded them down. That's what they look like. Look at all of these rings, you know. And then we also took some live cores of some trees that we could, just to try and place what we could. So, and it was just really, really crazy. You could see all the termite damage. That's what we were cutting through. We went through a lot of chainsaw oil. Just not a good situation. Trying to piece together a piece of history here. We also did fruit collection. So this is the orchard that my third generation great grandfather took care of during the long walk. And it was still very active. There was 4 elders down there taking care of this piece. They all died during COVID. And luckily, I'm working with the family, the descendants. They don't live in this area, but I'm working with the descendants today to try and keep them going. They don't have a lot of money, but I'm trying to help where I can. And they go down on the weekends, and they still take care of the churro sheep. They still take care and try and plant. They're still trying to water the trees, all while trying to raise their 3 kids, which are a little older. So there's a little bit, they've got extra hands to be able to help. But it's a hard situation. These are the trees that I propagated from that earlier photo. These are in Thatcher, Utah. I put bird netting that year just to get these fruit here to be able to try and do these comparative analyses. So fruit size, we're not going to go through this too much, but essentially these were collected both from Navajo Mountain. There was a white fleshed and a yellow fleshed peach, and then this was grown. This was a descendant from Canyon de Chelly, but I had this growing in Thatcher and this was growing in Thatcher. And so same thing, you can continue the pattern. But you see that these have a larger fruit mass. They were getting regular irrigation, whereas these were not, okay? So they had more water stored in them, and then more cell growth to be able to go with that. So they were able to grow a little bit larger. And then right here, this to like the seed pit ratio, there was just, again, comparing more flesh, okay? We're going to get on to density. The peaches that were grown at Navajo Mountain were less dense. They didn't have the irrigation. So this just paired well with essentially like us at looking at like fruit development, fruit physiology. As pomologists, they look at this. This is how they get to, we need to have consistent irrigation, because if you have consistent irrigation, then you can see like a higher fruit density. You can see that they're going to put on more flesh, and then so you got more weight, and you're going to be able to market more. Okay, you're going to be able to sell for a better value because you've got more weight, and we buy our fruit by the pound, right? So we get to these points, and we do see that over at Navajo Mountain, the infrequent irrigation reduces the amount of cells that are developing at the time of the early fruit development, and then the fruit are smaller also, and they grow more nutrient dense content rather than just putting in the moisture and packing that in. So it was just really interesting to be able to see that, and that paired well with what the elders were saying. We're going to skip this. I went through archaeology data looking at seed size and trying to do comparative analysis. Didn't see anything beneficial, but people ask me, did you do that? And I say, yes, I did. So, and then peach nutrition. So here's like USDA fruit label. We saw that like the fruit grown at Navajo Mountain and the fruit itself was more nutritious. So it had higher calories, calcium, fiber, carbohydrates, total fats. Sugars did not change. It had lower protein and fatty acids, but the sugar and potassium were not significantly different enough. But the thing is they're still more nutritious in a lot of other ways, right? So, and the question starts to pose, like when I thought about that, like what is it different in their system? They're getting less irrigation. They're living long years. Like we'll start looking at the dendrochronology here. Okay, you're going to see that they live very old, and they're constantly producing. But our current conventional fruit production systems, they tear out the trees within a matter of about 15 years, turn them over. They're constantly pushing all the fertilizer. They're getting all the nutrients. They're getting all the water, but their like longevity is not there, and the nutritional content is not there. So it really started to pose me in my early studies. I never had an answer, but I started to question like why? Why is that? Okay, we'll get to that. Genetics, we got into using 20 what we call modern accessions, so other peach cultivars, okay, from around the world. So these are the areas that we collected from. These are very common original breeding stock of peaches that we have today, okay. And then the selections that I had, and this is where they grouped. So what was really interesting is, you look at this and you go back to early science and you're like, oh, so there's a common ancestor way over here, which means like, oh, how did they derive? Like they didn't come off of that. When did they come off of it? Where's that common ancestor? So that's how I was looking at it. But the peach geneticist that I work with out of Clemson University, she says, no, this is just saying that they're so inbred. Like you look at the actual DNA patterns, they are so inbred, they've been growing in their communities for many generations. I said, well, what does it take to get them to be this inbred? And she goes, if you take a tree and you plant it, so your founding parent, and you plant that seed, it self-pollinates, which peaches can, and you take that seed and you plant it, you let it grow, self-pollinate, plant it. You do that 6 generations, you can get an inbred individual by around the 6th generation. I'm like, well, these trees, they grow in communities. So we've got cross-pollination happening. What would it take then if you're getting cross-pollination? She says, well, at least 50 generations. Okay, so just keep that in mind, okay? All right, so those blue areas that just showed up, those are, remember I said I was going to get back to what's going on in Hopi. Okay, so they're trying to repropagate, replant. They're trying to keep their heirloom seeds pure. But meanwhile, we've got fruit trees that are introduced from the 1800s. We've got people currently bringing in fruit trees, trying to grow fruit trees from nurseries that are growing these, genetics off of these cultivars here, and they're crossing, which is what these are here. And I know these trees so well. When I saw these trees and they were growing, they looked different before I even saw the fruit. And I told my advisor, I was like, those are going to be different. They're not the right peach. I already knew. And sure enough, like they start producing fruit, and the fruit looks like what you buy at the grocery store. And I'm like, those aren't it. But they did share genetics with these. So they do have a parent of this, and they have a parent of somewhere in here. Okay? So it was significant. But also, see how these group by their region. So they've been located in their region and inbreeding within their own local communities for generations and generations. So when did the trading happen? Right? When did we mix the seeds? Shouldn't they all, if we had traded and it was a single founder individual, like what does it take to also get inbred populations within your own local regional community if they were all sourced at one event at one time only about 400 years ago? So I start to question, okay? This is just another way to look at all the data, okay? Dendrochronology, so these are from the samples, the average ages, maximum age, sorry, not average age. And you can see in Hopi, some of these samples, they look like this. And working with the dendrochronologist, I'm like, the bark is worn off. We've got missing rings on the outside. How many years do you think have weathered off of this? And he's like, easy 10 to 20 years. So this is what I recorded. Add 10 to 20 years on top of these, okay? All right, so now we know about how old they can live. I also saw missing rings. So missing rings are like what you see common in junipers when they're trying to cross-date junipers. In a drought year, they don't produce a growth ring. And I saw some of those. I saw like half-produced rings, and then it wouldn't continue all the way around. So was there years that they didn't produce any rings at all? Or do they produce a ring every year? So there's missing rings. We know that. So they might even be older than what I've just shown you. This is just talking about their variability in growth ring size. So from ring to ring, what's their width, okay? And there's more variability in Navajo Mountain. And this is where we get to see the irrigation actually correlated with what the elders were saying and how they actually irrigated. The more variability you had, the more water was being added at different years at different times. And so we saw different growth rings every year based off of what the trees actually needed. The ones that have less variability, Zuni, absolutely no irrigation, followed more of the annual precipitation patterns very closely. But we still didn't have enough rings. We didn't have enough samples to be able to cross-date them. And I haven't been able to find any more samples because the trees are just gone. And so what I did find was lucky enough to have found. So just to wrap that up, 70 to 80 years of confirmed rings, isolated inbred populations, you multiply that, and at the earliest, if we were just to do that 6 generations, that's putting you right at the time that Coronado's coming into Mexico. Okay. So it's a nutritious food source. So I'm going to stop this here, and I'm going to open up another presentation to now carry on to what I've been doing the last 4 years. I've had several life changes. I had a baby, lost a husband, and in that time also did not get to complete the genetic work. I had funding to continue the genetic work. I had some samples. I've just been trying to get my feet back under myself over especially the last couple of years. But we've done some interesting stuff since then. So I had another orchard, another research trial established back in 2021. And, or actually, I think earlier. I think I established it back in 2019, the year that I moved and started my job. And it was 2022 because I was pregnant. No. Yeah, it was 2022. I was pregnant. We had 3 years of growth. We direct seeded them, compared them to level rootstock. Peach rootstock is a very common peach rootstock that's modern industries grafting onto. And we did comparative analysis looking at the roots, okay? And what sparked it is, we'll go through this, so we've already looked at this. This was a different presentation I gave. But we wanted to look at traditional management practices. So I think this is really interesting because this is one of the orchards that I sampled one of my favorite trees from. The fruit tastes like a cinnamon cling spice. It's yellow flesh peach, very delicious. There was only 3 seeds that we got, and only 1 tree made it, and I am like holding on to that precious tree. But this is the mother tree of that, and the family continues to till, and it's eroded away, and you can see the root system. So I was like, oh, I'm taking a picture of this because I'm going to be presenting on the root system of these trees here, and this is just going to be really interesting to like look at that. Like, I don't even know how old this tree is. You can see they've cut off this branch, they've cut off that branch. There's no way to date a root system. But some of these roots are even bigger than the trunks, So, like, how old is this? I just keep asking. And it's really interesting. But we go through and start characterizing all of the sites. And earlier in my studies, around 2018, we did a controlled experiment in a greenhouse looking at that comparative, like, let's dry down, let's get level, let's get Navajo. We grew them in containers. These are all of them mixed in, randomized, growing in the greenhouse. They get the same amount of water. We can measure the water. So they're on scales, each like very high precision controlled environment. We controlled the temperature, we controlled the humidity, controlled the amount of light, everything. And what we saw is Navajo were able to recover more. So this is transpiration of moisture. So they transport more moisture, and then you can see the dry down. So they got irrigated, they're taking in moisture, and then they stop getting moisture, and then they dry down. You can see Navajo, and we dried them down to what we call our permanent wilting point, which is essentially the trees are they're wilted. They're not taking in any more moisture. There's no way that they can take water up anymore. And we did this several times, over and over and over. And what we saw as an output is they put on more leaf area. They had more leaf tissue still. Their root systems were more constricted, and they put on more weight. They were bigger, they were denser, and they recovered a lot quicker. So they took up the water very quick, very rapid, and they were able to recover a lot quicker. Okay. So that led to, well, let's look at this in like real-time environment. Let's put them in the environment. Let's put them in. Let's see what happens. And so we direct seeded them. We measured them every year. This one's oops. I just want to point this out because I think it's funny. I was really upset because the deer bit this one and it turned into a little bush. And the rest are starting to grow up in really big trees. So we had that happen. The first time I direct seeded, some of them didn't come up. And I think it's really funny. The next year I direct seeded again at the same time, got new liners, so we had several replications. And then we still only sampled from the first year's planting. So I'm like, I did all the work in the second year just to not take any of it. And we didn't have good success the next year either. But all in all, we were able to find out some data. So we took core samples. We went down. This is how we laid it out. We went out from the trunk at these distances, and then we went down at these depths, okay? And what we wanted to see, what we do with this, and this is done with asparagus. This is my other major professor, Dan Drost. He's now retired, and this is Brent Black. So we're going through, and we're actually like on excavation day. We went through, we cored down, we took those samples. We can look at how many roots are there. We can look at how thick they are, what types of roots. And so the plants are taking up nutrients in your fibrous, very small hair roots. If you've got the scaffolding roots, those are more just for structure. They're really not taking up any nutrients, water, nothing, okay? And so that's how we first sampled, and then we took it out after we got those, and we deep down excavated. We cut off the tops. We measured how much above ground biomass there was, because that directly correlates with how much volume and capacity that we can start to look at as how much they're actually taking up into the tree from their root system. Okay, so we can correlate that as far as some of the below ground mass of the plant. Okay, this is where it kind of gets a little like, I'll point this out. Level liner was the plant that we ordered from a nursery. They were starting to grow off in a container to begin with. They were not direct seeded. But I got seed, and we direct seeded, and then we direct seeded Navajo. Okay, so there wasn't any difference in our trunk cross-sectional area, which is that correlation that I was telling you about of the expansion of the trunk itself and how fast they grew. And we can directly correlate that with all of the mass above, okay? So there was no significant difference there, which is what these A's mean. So if they share the same letter, then there's no difference between them. They all had the same growth, support, everything, they grew the same. Now, stump biomass, we took the stump and we weighed that, and that's what this is the weight of that. Again, no difference between any of these. But right here, we start to get into looking at the roots and doing some comparison. We have more analysis to try and pull from this still. So we're still pulling, like looking at all the data. But when we get here, again, there's no significant difference. We're able to pull out more like lateral root diameter and vertical. So lateral going out, vertical going down. Okay, so lateral outward going out, we didn't have any difference. But here, going down, we saw a difference in their diameter. So level liner versus both seedlings, and then just the rootstock. But seedling and seedling, they actually responded the same. So this is something that's really interesting, because as we started, we'll look at some pictures here, but as we started really looking at these and taking pictures, we started to see that Navajo had thicker roots across the board. Okay, and as we start to try, what we're trying to do is recreate the whole rooting system and looking at that. You can see that it has like a massive taproot that starts to go straight down, whereas those that are in containers, there's really no massive sinker taproots that are going down. They're very going out, they're very much more skinny. They had more fibrous roots, so they're taking up their nutrients right here at the top of the soil, whereas these trees, seedling, are going straight down. They're starting to source water. They're getting themselves up for establishment and really trying. And we saw this consistent. So these are just some of the better pictures that we picked that could help demonstrate this. And then level also, like they were able to spread their roots out more. So this starts to question, like, is the nursery industry doing everything they can to actually be more like sustainable in the long run, encouraging trees to be more drought resistant, or should we pick up different practices? But this is showing like what is significant about seed propagation with these trees and why it's been so successful for several hundred years, okay? So with this, we're thinking that the way that if they're direct seeded, this contributes to their drought resistance and their success, because they're not just getting everything in a small area, they're having to be forced, and they've adapted to sinking their roots down. Another thing that was really interesting is in the orchard industry, if you guys have seen a commercial orchard, you see that like 3 feet out from each side of the trunk, they have an alley of cleared vegetation. And they do that because the tree roots, they need them to spread out. The minute that they hit the grass line, or what we call the drip line from the tree, the roots actually start to go down, and they don't compete with the grass. But they want the grass there because they want to help with soil moisture retention. They want to help keep dust down. They don't want dust on the fruit, on the tree. It starts to cause pest problems, okay? And so, but that's a common problem in commercial orchard practices that they see, is there's no great competition of a fruit tree and other vegetation, so you keep it clear. But with these, we saw that the roots kept going straight directly into the grass line, past the grass line. They kept going. They can compete. They've learned to associate with multiple different species of plants and grow in these communities, okay? Which is what you saw in that picture of where they're naturally growing. Like you've got, like you can take the corn, beans, and squash, and everybody, you know, out here we don't plant them all in the same hole. We actually keep them separate, but they're still grown amongst each other, and they are spread out. Okay, you have your corn, you've got your squash, your melons, your beans, and then you've got the story of the orchards getting collection of the water running off into these alluvial fan plains, and it's capturing, and they're able to function that way. We've also done peach cutting propagation. This is data that I don't have for you. We've collected all the data on this, but we haven't gotten it analyzed, but I can give you some like first observational results. And the reason why this sparked is not only because people were asking, like, can you propagate them from cuttings? Like, would that make your job easier? And I thought, you know, I would really want to. But what I kept being told was they look great when you start, but they run out of energy, and they don't actually like the cutting doesn't actually root well, and it won't grow up. So I'm like, started to actually look into it last year. So instead of doing the genetic work, I actually started to do this, because right now the trees that I first planted up in Thatcher, Utah are actually potentially going to get completely removed at the end of this year. So I'm trying to do what I can right now to propagate them. So that's what I focused on all of last year, was let's get these propagated. Let's see if we can preserve the genetics. That's my whole focus. And we can do a project out of this and see, like, is it going to be successful? Is it not? And meanwhile, like, still trying to figure out, like, asking them, please don't cut out my trees yet, because I cut out every single other tree in that orchard but mine. And they're waiting for me. So now I'm just like, what am I going to do? But just looking at this, like, I'm working with New Mexico State University on this. This is Kevin Lombard. This is Bud Lopez. And so I drive out to Farmington, New Mexico. It's the closest facility that I have to a greenhouse out in Blanding, Utah, instead of going all the way back up to Logan or Kaysville, where they really don't have any greenhouse space because everybody else has their projects going too. So we work together. We've got great interns. They've got a really nice new greenhouse facility, and we started getting them up. This is us starting to measure and see, like, is there any rooting going on, and starting to collect and record data. So that's what they look like when we first got some of them planted in. I'll go into what we've done so far. So these are all the locations of the trees that are up in Thatcher, Utah. This is their original name tag. So this is Canyon del Muerto, Site 1, Navajo Mountain, Site 1, Site 2. Site 1, Hopi Second Mesa is what that stands for. Site 1, Canyon del Muerto, Site 1, and then Hopi Second Mesa, Site 3. And these are the colors of the flesh of each of those peaches. So I've got several trees in each of these. I think Navajo Mountain, there's 12. This should have 12. This one, or maybe 13, 12. And then there's about 5 here and 1. This is my favorite peach here. There's only 1 tree there. So, but we took cuttings in July. We had some semi-hardwood. And then there are trees. These trees, they just don't put on a lot of growth, some of them. And so we have some trees that had both semi-hardwood and hardwood cuttings, which is where the semi-hardwood is like that year's growth. And the hardwood is 2 years or a year of growth or older tissue. So by that time, it's hard, very hard wood, okay? The semi-hardwood is that year's growth. It's still very tender. It hasn't really what we call lignified. It hasn't hardened too much. And so, but this is what they look like when they were going in. They were really cute, really, some of them were sending up leaves and starting to open up. we did what we call an IBA growth hormone auxin treatment with hormone 1, hormone 2, and no treatment. So these are just different concentrations. This is 1,000 and this is 2,000 parts per million. And that's how you can tell the difference. So overall, since we haven't looked hard at the data yet, right now our propagation success was very minimal. I'm really sad. We had the cuttings that did root, like some of them, it was really interesting. They all looked good. The top stem was maybe lush and green for about 2 months. And then by the time like we go back and check on the 3rd month, that greenness had died. And some of them, like as we've looked at them, they have a lot of roots on the bottom, a ton. Like some of them rooted really well, but they just didn't have enough energy to like send it any energy up. So I don't know if it's something with the hormone growth. We also saw some variability where depending on the location, I think there's going to be some differences on the regional, like original location of origin and how they do. Because Navajo Mountain had a lot more hardwood. Like even their peach pits have some of the thickest wood like shell around their pit that I've seen out of any of the trees. So there's distinct characteristics that have adapted from where they've been locally grown that I've noticed and I picked out as I've been working with them for these amount of years. Just really interesting, but we're waiting on the data to be able to produce, but we're going to be putting that out and I'm going to be presenting that at a big conference this summer in July too. So we're working hard to get all of that done. I brought this picture up last time because it was just really interesting that in 2021, when I visited, like the story was just barely getting out and people were starting to recognize it, and I was just trying to keep up with like misinformation that was coming out about my story. I wanted to be able to tell my story the way that it happened, not how somebody else saw it. And with that, people started reaching out. So like I've had somebody reach out from Iowa, and they're like, there's these heirloom peach trees, like nobody knows who they belong to, but they produce peaches just like the ones that you're talking about in the Southwest. So now we've got collaborations building. I've got massive amounts of people coming and several different tribes that want to collaborate, several other people that have said, have you worked with these communities? There's one tribe, I was trying to track down the name. I got to call the guy again because I didn't write it down, but there's a tribe in California. The guy is like, they have purple peaches. And I'm like, I've heard of purple peaches when I was doing all the genetic analysis because our geneticists that we work with, like they have that as part of the scoring card of how we quantify characteristics. And I was like, man, wouldn't it be fun to see a purple peach? And I'm like, one that's local, that potentially is from these heirloom trees, like that would be really cool. I wonder what that tastes like. So I'm just getting really excited. We've got some trees growing from Wisconsin right now. I need to do genetic testing on, and it's just like with everything layered on since 2022 to now. Like now my focus hasn't been the genetics still. Like I'm trying to keep pulling those resources in and keep those samples. But I got to get more funding to try and analyze them at this point because I didn't get to use up my funding that ended in the fall of last year because I was busy working on trying to propagate these trees to keep them alive and preserve the genetics that I do have. So that's kind of what's happened over a little bit of the time. But we've got a lot of great partners. This is my main advisor, Dan. There was 1, 2, 3, 4, 5 people in that picture. And so I have my wonderful last son that's joined us in this journey in the last 4 years since I've been here. So, but all of this starts to tie into, I brought up permaculture and that brings an end to my slides, but going back to what's making these trees sustainable with little input, no fertilizer, no water, like what is it? And it finally dawned on me that this time last year, I met somebody that started to connect all the pieces for me, and it was soil health. Completely tying directly into soil health and not disturbing the soil and allowing the life that we don't see in the soil to be able to thrive. That I am pretty confident is what is allowing these trees to be successful as they are. We're not putting chemicals on. We're not killing the soil. We're not putting salts in the soil. They are naturally thriving and living with a local ecosystem that has not been disturbed and that's how they are doing it. And so I'm diving heavily in because it wasn't a part of my education to get the background of soil microorganisms and how they improve that and how they make food more nutritious. I'm very confident that is the key, and that is the key to success, and that's how we need to go back, because everybody keeps asking me, how do we go back to this? Like, how are the trees producing overload amounts of fruit on an annual basis as long as there's not a frost that happens? How? And they're not pruning, they're not taking anything away. There's nothing going back into the system. It's just the local ecosystem there and how it's been undisturbed and how it's been allowed to thrive. And the only input that we provide is assisted irrigation here and there if needed. But otherwise, they've been able to adapt. They've been able to sustain themselves. So I don't know what time it is, but that's what I have for you. I can go into more stuff, but that's the trail that I'm going down. In addition to continuing to preserve these peach trees, I'm going to start actually going through using GIS mapping software to start tracing all of these things, because it's just been a lot. And I knew that taking opportunities to come and speak to small groups, large groups, that eventually, there'd be enough of my voice around telling my story that I would be able to control anything out there that's going out. And it just so happens that I've been privileged to be one of the top 3 scientists to represent science in the state of Utah and speak on Science Friday. And so I'm very pleased to be there now and to be able to be a public figure in some extent for science, for my local heritage, to preserve an old way of agriculture, and to start actually being an advocate for that the old original methods of agriculture, not just Native American, but even this goes into European and other countries and how we practiced agriculture historically and how we honored and respected the landscape, and we lived with the landscape. We moved with the landscape. We didn't just live on it and dictate what was going to happen to the landscape. So that's a lot of where my advocacy is starting to come in now. I guess I've been called a food activist, a Native American, a tribal food activist, and I'm like there's so many names that are being given to me, and I'm not even thinking about them, and I'm just I guess I can be if that's how you want to label me, I can do that, So that's where I'm at today, and I'm really pleased to be able to come back here, 4 years later, and be able to share where we're at and why I'm not much further on the genetics than I had hoped, but it's still growing, and we're still progressing forward, and it's been a really great journey so far. So thank you.
Thank you, Reagan. If you have questions for Reagan, will you please go to the microphone? Or if you are on the chat, on the live stream, put your questions in the chat, and they'll get passed on to Reagan.
Is it on? Reagan, thanks for coming back. Question about traditional uses, if you know of anything you can share, of the leaves of the peach trees. I've recently learned that they can impart some interesting flavor, and so I'm curious if you have heard of that use.
Yeah, I haven't heard of cooking, but they are used for dyes for textiles. I can't remember which color they give off. I need to track that down a little bit. I think it's more of a lighter yellow green. It might be along more of that color with the leaves. I have heard that uses of peach pits, and you can look this up, it's in Chinese medicine. One of the elders, he told me this, and I didn't document it, but it was just in passing, and he's like, don't tell anybody. But now I'm actually going through a personal, advocacy for personal health and use of herbal remedies, which I know is a big no-no for pharmas, big pharma and stuff. But I was told that if you use the peach pit, you can press out the oils, and you can rub that on your head, and it can help with baldness. Okay. Now, what's funny is baldness can be related to a lot of different things with your health too. I think everybody's it's a genetic thing. It's a genetic thing, and maybe there is, that truth can still be there. But what I've been reading up is a lot of our chronic diseases contribute also to hair loss. Okay, so does it have to necessarily always be that you have hair loss because it's a genetic trait that's passed down? Or could it also be something that's related health-wise? And peaches, peach pits, apricots, you can find apricots, they have a compound, it's B17, and it's a part of what breaks down with that cyanide component. And if you eat it and you take that in, it can help completely remove cancer, is my understanding, but these are things that they don't want you to know. And cancer and some of these other illnesses like that are like it helps reduce inflammation. Inflammation is a leading factor that is common in all of these chronic illnesses, autoimmune diseases. And so if you take that and it starts working for you, you start feeling better, your inflammation, maybe that's something to stick with. Not that it's a cure-all for everything that you have, but it could be something. And you can buy the supplement, the B17, to help with that. And it can also has been proven to help bring hair loss back. So I'm like, okay, so here's the actual science thing. So look into B17 because you'll start seeing some of the science behind it. And that's associated and directly derived out of peaches and apricots, and they're both cousin species. So just really interesting. I want to share that.
So a question from online. Frank McIntyre wants to know if there's an ideal elevation for these peaches.
So I don't know if there's like a not ideal elevation, but what I've seen is 4,500 on up to about 7,000 can be a good placeholder of what I've seen them being able, just by the locations that I've been able to identify and work with, they're okay in those elevations.
That was fantastic, Reagan. I have this, I was very excited about the soil health component, but I don't know anything about how you reconstruct a centuries-old rhizosphere. I mean,
Okay.
what are the, okay.
Yeah,
Go.
I am learning on this. So, and I didn't know if I was going to bring this up or not, but we can just barely start to touch on it, okay? Because this is what I've been starting to teach to people. I actually just taught this in Bluff. Oh man, okay, so this is what I've been getting into. There is a lot of lack of credibility with people that are in the soil microbial world and actually looking at regenerative agriculture and sustainable agriculture systems. It's completely cut down, and the common science community is not recognizing it at all. Okay, or if they are, they're like, oh well, there's pieces. Like they somehow just like put all this stuff in. They put all of these things in to get it back to where it was. Which is what we recommend anyways, but they're not looking at the soil microorganisms in that. And also they're not taking into consideration that our agriculture here in the United States and in big first world countries that have gone to high conventional tillage systems, high fertilizers, high inputs, they're never giving back into the system what the soil needs, okay? So I just go through and I'm like, okay, so this is what I learned, okay? We're just gonna go through this. Have you guys seen these before? Yeah, this is basic science. If you guys have an education in like any kind of environmental science, you have that. But I like to touch this here. Like main focus in current agriculture is yield. So they want to produce a lot, maximum production, quality, large size, clean appearance, sugar content, sugar. They're looking only at sugar. It's the easiest nutrient to measure is how much like sugar is in there. They can do that with the Brix reading. But nutrients, they're not looking at. Okay, sugar factors into taste and how well fruit can store. If there's more sugar, if it's too high, storage quality goes down. So, but they also want it to taste sweet because they want the consumer to like it. So that has to be a balanced thing. Storage, processing, packaging, long-term appearance. That's all they're looking at. They don't care about the system and whether it's healthy. They don't care if you're healthy. They just care about producing something and putting it on the shelf and making it look good and pretty, and making sure that the producer gets the most out of their buck. And that's it. So we go on to what plants need. What do they need? Okay. When do they need it? So in its early life, they don't need much. So they need low nutrient amount. Their root system's small. They don't have a lot of leaf area. They really don't need much. During this period is when they need the most. This is the same curve that we see with the fruit production cycle. They're putting on the cells early on. And right here is a critical period where they need to have the most amount of cells developed and divided, because after they get to this point, They're basically working off of the cells that they actually have. Same thing with the plants. Like this veg, actually it's different. So with the fruit, it goes like this. It goes up, and then it flattens, and then it goes up again. This flattened period is a correlation to like right here, basically. So, but nonetheless, they're putting on leaves. The more leaf area you get, the more photosynthesis you have, the more sugars you're producing, the more fruit potential you have in the outcome. If you have less leaf area, you're not going to get more. So this is plant physiology, scientifically proven. Yes, it's true, okay? They stop needing nutrients when they actually get into reproductive because all of this work, they're storing it in their roots, they're building it in their leaves. They actually shut down a lot of that, and it all goes directly to here. So everything that they collect here then goes to what are you actually going to have at the end. Fertilizers. We get into organic, inorganic, and the plant just needs a nutrient in a common molecular form, one type of form, okay? And it doesn't matter if it's organic or it's inorganic, they just need it in that molecule, okay? So that's what we're taught. So it's up to you guys. Do you want to buy organic? How do you want to sustain it? But nonetheless, in my mind, I'm like, it's still a fertilizer. You're still putting in something instead of trying to figure out what is actually going on in the soil. How do we sustain it without having to put anything in it, right? And then we're always taught to tell everybody the key to knowing how your soil is doing is the soil test. Okay, what's your nutrient content today, and what do you need to add to make sure that you have enough for your plants tomorrow and following up. Now, to me, I'm like, I went through a health journey last year. I was really sick. You go and it's like, let's go test your thyroid. Today it was great. You know, you may come back, you know, they don't see anything, but you still feel like something is wrong. And you're absolutely right. Something is wrong. But a test doesn't tell you everything. And that's how I see the soil test now as an extension agent. I will tell you, I will be honest. And I know I'm being recorded, so. All right, so you get into the nitrogen cycle, okay? Nitrogen is the, one nutrient that plants use the most, okay? And it's highly mobile, it's highly rare to make sure that it's there and available. So we add it as a fertilizer. Ammonium sulfate, urea, okay? This is the nitrogen cycle. So we have ammonium right here. You have oxygen input and you get nitrite, and then you have more oxygen input from nitrogen oxidizing bacteria to get nitrate, this is what the plants want. This is the nitrogen form. This what helps makes your leaves nice and green, okay? And this, they can take up this form too, but it usually gets bound in the soil, and it's harder and slower for the plant to take it up. It's easier for the plant to take it up this way. It's very mobile, moves really fast, and they like it. This, if they take it up in this way, it goes to make proteins in the plant, okay? And proteins in your body help make sure that you're having hormone exchange, your body's recognizing things, it's receiving things. If you're taking pain, it's got a receiver, right? Receiver, receptor. I don't know if you guys have learned about that. Some of you might have. But then it goes to denitrification, which is nitrogen gas, and it goes back into the atmosphere. So this is the toxic form that everybody's like, farmers just keep adding too much fertilizers and we've got a lot of nitrites in our water, okay? So, but this whole process has to happen in order for the plants to take it up. Okay, but it happens naturally in our systems too, very natural. So what does that look like? You've got nitrogen-fixing bacteria, and this is usually associated, people associate this with only legume plants, okay? But that's not always true. There are bacteria in the soil that help fix it into a form that the plants can then absorb, okay? You also have the animal impact. If you have animals, okay, then this stimulates soil organic matter, starts to increase because now you're inoculating microbes into the soil. You're also providing food for the microbes to decompose and digest. And as long as you've got good organic matter in your soil, it's easy for them to continue getting their food, breaking this down. And this is not just in nitrogen, it's other nutrients too. They break down the nutrients in the soil to make it available for the plants directly. Okay? So How many of us have animals in our landscape? Not many. How many of us have heard the advocacy for removing animals from the landscape? Okay? Okay? All right, so when we get denitrification, we speed up denitrification processes when we have a lack of oxygen in the soil from waterlogging or poor soil structure. Those two factors can contribute to denitrification, loss of nitrogen in our system, okay? Now, one thing that we haven't touched on is we've got ecological succession, okay? These are early succession plants. These are late succession plants. Have you guys heard of ecological succession? Okay, your forests are more developed, okay? But there is a system here with microorganisms that is barely being touched on and discovered in the last 20 to 40 years, okay? I think people have known about it, hasn't been very recognized. More people are starting to recognize it now, but they're not being heard. So now we're at a point where there's enough data and science out there. You can look at research on Google. You can start looking into this. There's plenty of research. I think we actually have all the research we need to start looking at climate change and our food systems and nutrition, our chronic illnesses. We just need to start working together as professionals to start pulling together all of the work that we do wonderfully and start creating a full story, okay? So you have more bacteria proliferated soils over here. Your fungus proliferates over here, and they have a relationship with your forest trees to exchange those nutrients. We know this. You find more fungus in forests, right? Very, very recognized. Your bacteria over here in disturbed soils, fungus cannot thrive over here because the soil is disturbed. There's lack of oxygen. Usually this happens from a destruction event. So what can be a destruction event? Tilling. What else?
Herbicides.
Herbicides could be destructive, yeah. What else? Fires. We have natural destructive events, right? So Mother Nature has a way of repairing herself when she has a destructive event. But we are also being destructive on the landscape. Mother Nature allows rest. Mother Nature allows the cycle to go over and continue when and where needed. But we come in and we keep repeating the cycle over here. Fungus cannot survive a tillage event. So we're just having bacteria in our soils. But what type of bacteria? Because what does tillage lead to?
Hardpan?
Hardpan? Okay, so that's another thought of compaction, right? Okay, and what did we say? We get denitrification processes happening from poor soil structure, and part of that poor soil structure, waterlogged soils, there's a combination there. There's no oxygen, okay? So when we start getting into microorganisms, and I don't have them broken out here, but this is just to show that there is a lot of research out there. These are like rhizosphere conflicts. How do you restore the rhizosphere, right? That was the question, okay? So this is just looking at like, this does exist for many types of plants, okay? These plants have been in these relationships and evolving with microorganisms as the first evolutionary living structures, and they form symbiotic relationships without actually being attached to each other, okay? And they work together. Yes?
Do you think there's evidence of the ancestral bacteria
In the soil. So bacteria are everywhere, right? It depends, and they can thrive anywhere, as long as you create the environment that's going to sustain them. So, yes, they are there, but have we created an environment to sustain them? When we remove animals from the landscape and we start massively tilling up thousands, millions of acres.
I meant for your peaches.
For the peaches. That I haven't looked at around the orchards yet. Okay, so I'm just barely learning about how does this system work. So that's what I'm sharing with you. I think it'll be interesting because I do want to take it to that extent of actually going into these historic orchards. People have told me about let's look at pollen, ancestral pollen dating in the soil. Let's look at that. It's just a matter of getting the time to do it and getting the funding to do it. So I think we can do it, and it's definitely on my mind. But we're going to see each plant they have specific types of bacteria that associate with them, okay? So this is where we start getting into, do we need a crop rotate? What's monoculturing, right? Let's look at the ecosystem, right? Do we have one type of species in a natural ecosystem that's undisturbed, that's been thriving and coexisting? Or do we have multiple? We have multiple, right? And with multiple, you create a balance of different microorganisms that support each and every individual species, okay? So you're no longer creating an environment that's just supporting one plant, certain types of microorganisms, and then you cause an imbalance. You're creating an ecosystem that supports multiple species of bacteria, microbes, plants, and vegetation of the like, and there's not an overbalance of any one over the other, okay? So maybe we don't need crop rotation if we figure out how to grow multiple species of our garden plants in and amongst each other. Bringing back a clue, the three sisters. We can also add the fourth sister in there, right? The bee plant or the sunflower, whichever one you want to call it. I like to say the bee plant. But that's like, you think of how an ecosystem's thriving. And why does this work? Okay, so we go back to this. This is our point right here where we start seeing fungus. We actually start seeing soil start to get more acidic with more fungus breaking down and working that soil. The higher pHs are over here. You have your cyanobacteria, your poorer soils, and your weeds. Everybody's like, oh, well, I just can't get the weeds to stop being weeds. Well, what's their purpose? What's the purpose of a weed other than to just be a nuisance in our brains? They're breaking up soil. They're starting to help reenact this beginning process of breaking up the soil, getting oxygen back in the soil, allowing channels for water to get into the soil, because right now it's been disturbed. There's no oxygen. And no oxygen, you have two types of bacteria. So if we're looking at just starting off with bacteria in this site, and all we have, two types of bacteria, there's aerobic and anaerobic. Those that need oxygen and those that don't need oxygen. We have both types in our bodies, okay? The minute we die, we stop taking in what? Oxygen. And the anaerobic bacteria take over and we start bloating and decomposing, okay? Same thing happens in the soil. If we're not providing pore space, good soil structure for air and water, we don't have oxygen to get in, and we start feeding and supporting the anaerobic bacteria, which are your decomposers. And so we have more pest problems. We have more diseases coming through, all these things, right? So we can keep going.
We're good.
We're good? Okay, let me finish real quick. So poor soil structure, we get here, we can hold more. You want to have, this is your takeaway. This is how you want to set up, and this is coming from Ray Archuleta. He's a certified professional soil scientist. He worked with NRCS for over 30 years. He now runs the Soil Health Academy, and he came up with this. If you don't have earthworms, if you don't have living roots, if you don't have spaces between your soil aggregates, you don't have any structure, it's just tilled soil. If you don't have dead organic matter to feed your microbes, and you don't have living plants to conduct, and you have bare ground, you're going to have poor soil structure. So the best things you can do is cover your soil, okay? And in the desert, that's really hard. But we're at a point where we've lost so much life, we need to give a lot back in because we've taken so much away. And I think that's a concept that's really hard to understand for a lot of people nowadays. It's like, oh, well, I have to do all of this. They say I have to put all of this compost, all of this material in. Like, where am I going to get all that? But once you get it set up and you give it, you're patient, you wait 4 to 5 years, it'll start giving back to you, and you'll start repeating the cycle. And the plants, the trees, they drop their leaves, they add decomposing organic matter. You leave the things there so they can decompose. So that's how we're looking at these systems. And that's how we did it even in our old time. We didn't remove the crops. We actually tore down the corn stalks, left them there, let them decompose, and we come back and we plant back in. We were doing this system until we were told to do it a different way. And we weren't tilling. We were using digging sticks. And the soil becomes fluffy. When you get the fungus in there, it becomes fluffy. And it soaks up and holds the moisture. And it retains the nutrients that you need, and it breaks it down. And those aggregates form and bind together with the roots of the plants to be able to do what they naturally do. So that's how you do it. You have to give back. Yes.
I was curious if in your visits to the heritage orchards, in your analysis of the sites, if you saw any evidence of earthworks used for water harvesting, or if you heard any anecdotes from elders about water harvesting techniques.
So a lot of these places where the orchards are established, again, they were in the alluvial fans. So the orientation of how they would plant the trees was in a way that the trees would help capture and slow the water so the water would find its place and not just keep running off. So that's one step. And plants are good at doing that. We just talked about weeds even doing that, right? Their soil structure, okay? So any type of vegetation helping to capture that. Corn, I've been told, like the old ways that we planted our corn as Navajo people was actually in the spiral, okay? And it wasn't in rows, like it was still in the bunches, several holes in a seed, but it was in a spiral, and that also helped aid and capture water. In areas where you have the springs and you want to channel that spring source, they would get the sandstone and they'd form a whole wall and actually pipe and channel the water in. And there's several places where I've seen this where they've actually even carved and etched into the sandstone to channel the water, like really small, slow streams. And you've seen some of this actually in like Iraq and Iran. There's some really old farming sites where they've like had like 1,000-year-old irrigation channels. So like I've seen some of these, and like the one at that one orchard is still in existence. They've just kind of dug down and trenched it, and they channel it, and it's just really interesting. So you start to get really creative. Like the amount of water that's coming out of here in the desert, you can channel, and as long as you place it, and then you have the vegetation there to capture it, and you're allowing the system to feed itself, you can get an oasis in the desert. It can happen.
Thank you very much, Reagan.
Thanks.